Hi guys, and welcome to another episode of the Performance Series. This is Chris with Microsoft, aka Big Daddy Nines. Today we're going to be talking about processor performance, and this will be the first episode where we are getting away from memory talks in quite a while here, so nice fresh topic. We won't be on this topic nearly as long as we were the memory. It's not nearly as in-depth to troubleshoot the processor performance as it is to troubleshoot issues when we're talking about all different types of memory and stuff. In fact, it's not all that different from troubleshooting problems live. Okay, where's my little tool for this? And I'm looking for CPU stress. Right. So if you're troubleshooting live on actually let's not do that. Let's do this and this and this. When you're troubleshooting an issue live on a box, what do? If you suspect there's a high CPU utilization? Well, you open one of these tools typically, right? You go to Task Manager. Most of us, I'd say, probably still go to Task Manager first, and we start looking to see, which of the processes is banging it up. Now, a lot of times, we're looking through memory and disk and Ethernet and all this other stuff. We're trying to figure out what it is that's bottlenecking the server. And then once we see really high CPU utilization, kind of bottleneck and I guess we should probably have some higher activity if we want to make this thing busy, right? Let's see if I can do that on a couple of threads and get this thing nice and jammed up. So what most people do is, obviously what we're doing here in the picture is we're seeing, so we're seeing high utilization from a CPU perspective. So what do we do at that point? Well, typically we go straight on over here to details, and then we sort by CPU, and we see who it is that's beating us up. CPU stress in this case. And you might actually be going over to resource monitor. You might be over here looking at percent of CPU and resource monitor, and kind of doing the same thing just with a slightly different tool. And at this point, this is not respond. Oh, I had it. Error, click it again. So here we go. CPU stress is, now if I could just aim my mouse, we'd be in good shape here for this episode. All right, so we can see, bang, problem solved. That's what's actually taking up the the majority of our clock cycles here. We might even dig in a little deeper and check that box like we've done in a previous episode, just to kind of recapture what we've got going on here and maybe tune this whole noise down just a bit so that I can get a few free cycles. Get back over to CPU stress and tell it to turn that volume down. And I may have toasted this thing to the point where it won't respond, but I think eventually she'll free up. So what we have right now is a processor queue. What means is I have clicked on something and the system is waiting for free clock cycles to repaint the screen and give me CPU stress. There we go. So maybe we don't need all of these to be active, and maybe we don't need all of them to be busy. Go back to medium maybe and give the OS a little breathing room. And we can see the graph is now kind of taking a dip, but CPU stress is still kind of here up on top. So this is nothing new to anybody on this video here. What you may not have done is notice that if you can get into Resource Monitor instead of Task Manager, you can see what it's doing. You can come down here into the handles, and we can see all the things that CPU stress is actually touching. And as you can see, mostly it's touching some registry stuff, and it's got a handle full of, should be some files. So yeah, there are some files that is what makes it what it is, right? And there's some modules as well, kind of a similar thing. So we got some DLLs. That little bitty program is actually touching quite a few things. You'd see this in Notepad though. Even little bitty Notepad, when you pull it up, you're going to find that there's actually quite a few handles and modules that are loaded. And when you're troubleshooting issues, it's nice to be able to kind of pull down and see what else is going, especially in the services area. For CPU stress, not so much, because there's really not a service. There's not much going on with CPU stress. It's just kind of a little standalone program. But what if the thing that was beating us up was SVCHost? And we've talked about this before, but just to reiterate, since now we are back into the processor troubleshooting module here, SVCHost is a service host, and what its job in this world is to do is to host smaller services so that we don't have to have one entire bucket of process for every single service on the box that maybe doesn't do just a whole heck of a lot of stuff. But if one of them is sitting at 100% processor utilization and you need to know what it is that that's doing, the description is right over on the left where I'm kind of highlighting in blue. And if you notice, some of them are fairly descriptive. And if I were to look at network services, for instance, and wanted to know what of network services is taking up my CPU utilization, I check the box, which pins it to the top up here. And this gives me a list of things that it's doing. So now you can see services is populated. This is all the things that SVCHost is in charge of. So the device setup manager, IP helper, user profile service, background bits, the processes in here are all services, but these services weren't really necessary to have, it wasn't necessary to give each one of them their own 32-bit process instance, because they were just kind of little things that don't do stuff very often. But if they on your system are doing stuff very often, they may be pushing the CPU average up. You can sort by this here, and you can come in and see actually what is happening. The handles and modules below, probably won't use those quite as often, and if you have a handle leak, that's about the only time. You don't see that very often, but when you do, that'd be about the only time you do that. So this is kind of not new stuff, as I mentioned before. What this whole series is about is mostly about taking this to the next level, putting it in Perfmon, and being able to troubleshoot from there. And there are some gotchas that go along with troubleshooting processors, and so we're going to call those out along the way and talk about how we go about doing our thing when we're troubleshooting usually a box that is something that crashed overnight or something like that. Now we're coming back in the next morning. They tell you that the server was just completely unresponsive for hours last night. If you've got a black box counter running, which I'm going to teach you how to do in another episode, you can come and pull up your Perfmon and do more or less the exact same thing that we just did here, which was we saw high CPU utilization. You're going to go find that in Perfmon. You'll see that's one of the primary indicators, just like it was on the task manager graph, and that's what we were looking at. And then we go and sort by processes and go see which one of them it is that's taking up all our resources. So as usual, we'll go ahead and kick off Perfmon and get her going. And we'll talk about some of these counters that we're going to be using. And we've already got a user-defined data collector set in here, but that was from memory, so we'll go ahead and dump this, and we'll just create a new one. Practice our skills at creating new data collector sets so that we know how this. We'll call this proc, and we'll go ahead and do this one manually. It's going to be not event, performance counters, and next. And what do we want to load in? Okay, so what you are looking at in the screen when you first load up Perfmon and go to the performance monitor, I don't even know what to call that, tab, I guess. When you go into that, the actual counter that's loaded, the only counter that's loaded, is percent processor time, and that's this one. So here's first gotcha. All instances. The reason for this is because with all instances, you can see a single threaded process that has hit 100% utilization, whereas when you're on just all instances, you might miss it. So we'll talk about that a little bit too, but just imagine, and we've talked about this a little before, kind of alluded to it, if you had a user who said, hey, the server is completely unresponsive, it's slow. Well, is it the server that's slow or the application they run on it is slow? For those of you Minecrafters out there, love using that example. If you know how to tweak your server, you know one thing that you really can't tweak very good is the processor, because it's a Java app and it only has one thread. So you can have a 16, 32 core system, however many actual processors you have in that box, it won't matter because it's only going to run on one of them. So I like to have all instances because then I get the total, which again is an average, and I know that is counterintuitive, however it is. Underscore total means average of the two processors in this case, or all processors on your system. Now, here's some other counters you need to be loading, because this is a little bit more than just using Task Manager or Resource Monitor. We want to go ahead and dump in the percent of privilege time as well. So either all or total, it doesn't really matter. I need to be able to see privilege time versus user time. because, and by the way, this plus this, privilege time plus user time equals processor time. So privilege time means kernel. Anything the kernel is doing, generally hardware related, is going to show up in that, and percent of user time is going to show up as anything that is in the user mode process. You've probably seen this before. When I right click on Task Manager and I show kernel times on here, it will actually change the graph to display kernel times as well. And at the moment, there's not a lot of hardware stuff going on with this machine, so it's not actually displaying that for us right now because those are low. They're also displayed in the resource monitor as well. And we're going to load that in, and I'll explain why in a little while. All right. So we also need to get in the set a couple of other little counters. So I want to know DPC time and interrupt time. So your percent of DPCs and interrupts, essentially what this comes down to is hardware talking back to the processors. When a hardware has an interrupt, in other words, it's finished with a job or it's starting something or it needs to talk to the operating system, hardware gets priority over pretty much everything. And it will cause an interrupt because if you're right in the middle of a call stack, there's some kind of an execution job that you've sent to the processor, or it's currently chewing away at that job, it suddenly gets an interrupt from a piece of hardware, it does a transition, it puts your job on the shelf, it processes whatever the hardware needed to say right then, and then it turns around and it continues to work on whatever it was working on before. Those are called context switches, and you will often see those context switches happening when we have lots of threaded processes going and they have lots of jobs, but you will also see a higher interrupt time when those switches or transitions, which is the better term for them, cause the processor to actually have to stop doing what it's doing. And we need to be able to measure whether or not the processor is spending way too much time on interrupts. So we'll talk about that in a minute as well. So we're going to go ahead and kick that in there. And looking back through the rest of this, don't think we need any of the rest of those, which means we need to go ahead and move out of the processor object and onto the system object, which is where we find the context switches that we were just talking about. System object, context switches per second, and there we go. Now, just like when we were troubleshooting Task Manager and looking for the process, this high CPU stress utility that we were using, we went and sorted by process, so it shouldn't be too surprising that we need to go to the process object and go pick some counters. In this case, we'll go ahead and dump in percent processor time and percent privilege time. I don't get user time since I am going to be able to infer the percent of privilege time and user time by knowing the difference between those two, so I dump in all instances, pop that in there, and that's pretty much the amount of data that I need to be able to grab troubleshooting performance issues from a processor perspective. So we'll go ahead and do these in 3-second sample intervals. Clicks next and finish, and dang, bang, we're on there and it's going. So we'll right click and start this, and then we'll go ahead and kick off our little guy here. Actually, let's not kick him off too heavy yet, and let's actually shut them completely off just to get a picture of what good looks like. It's always nice to have a benchmark of what your system looks like when things aren't bad. Knowing what good looks like is the first step in knowing what bad looks like and understanding it. You'll also notice that when I turned off the high CPU stress, right down here we started to see some kernel time data occurring. We were probably preempting some of the kernel stuff that needed to happen because we had some user mode stuff that was going on, and it was just waiting for those. And when we turned it off, it also could have been that when I stopped that program, it had a couple of little writes it needed to do to say, hey, we're not doing what we're doing anymore, and it either stopped writing to whatever internal DLL files it was reading and writing to, and at that point it didn't need to be going anymore. All right, so we'll go ahead and kick them back on again, get them active. We'll go ahead and kick, we've already got 3 of them in busy, so we should be able to significantly kick the tar out of this thing for a couple of minutes, and then I'll unpause the video and we'll continue looking at what we're looking at. Okay, while I was paused, I went ahead and messed around with some of these settings a little bit and gave it a good solid kick in the pants here. So we've got one of these threads running at maximum. We've got, highest on a lot of Busium, all pretty well solid it out. It's not at 100%, and this is a virtual machine, so it's it's a little surprising to me to see not to jet straight on up to 100% since these are all emulated clock cycles. But I go ahead and kick that process off or kill it and let it finish kind of recovering there, and you can see the processors are dropping back down in the graph here, so we can go ahead and stop our little counter, and our collector set is at the ready. So what we'll go ahead and do is open up that with the blue cube, remembering our method here is we do not go and try to open that BLG file by double clicking it in Explorer. We go in here, hit the blue cube, hit log files, hit add, browse out to our processor test that we had, and grab the data collector and go ahead and click OK. We're going to go ahead and knock in our primary indicator, which I'm in process, not processor, my apologies. Percent processor time. This is your key indicator. So remember how the troubleshooting process goes in this little troubleshooting tree that we've been talking about since day one. We're going to be given an indication from someone, help desk, neighbor, family member, friend, person in your work, if you are an IT person. This server, this workstation, this PC, this laptop, whatever was slow, and you've kicked off these counters and you're tracking now. All right, so what you've now done is we've run the thing through a point of failure, we have stopped our counter, we have loaded up all the counters that are being used in this series, and first thing you're going to load up is all the key indicators. And as a review, our key indicators for disk was percent of average disk per second read and average disk per second write. Our key indicators for memory were available megabytes and percent of committed bytes in use, and a couple of others there in the kernel. Now we're on to doing processor. This is our key indicator, the percent processor time, and you can do total, you can do all instances, depends on the user. We're going to go ahead and just do all instances so we can look what that looks like. And that's really it. Percent processor time is the only real super key indicator that I'm looking for when I'm doing my first brush over the capture and looking to see, okay, first thing I got to identify, was it network, was it processor, was it disk, was it memory, what is it that made this person think that this system was slow, right? So this is a key indicator, and with all key indicators we have some thresholds that we have to meet, and in this case we have something I was hoping we'd eventually have, and so I'll take a slight little deviation from our talk here and look right there. You might be asking yourself, why is there a big gap in the capture window? And this would be the gap right here. Why is that there? We at some point became so overwhelmed that Perfmon was no longer able to write to the log. Looks like we may have missed looks like about 3 or 4 samples, and that's not uncommon. But to go back to episode 1 and episode 2, if I were trying to save this out across the network and push my BLG, my capture, from another machine gathering this data, I guarantee that gap would have been a lot bigger and we would have missed even more data. But this type of thing right here is exactly the sort of stuff that you see when you are trying to capture. That's why I always run these performance captures local. Okay, so again, with all performance captures, with all of the key performance indicators, we have thresholds that we want to be warning about, and so what we would want to consider to be kind of a key initial indicator, just a warning level, which is why I'm using yellow. It's kind of yellow alert, I guess, is going to be at the 50% range for extended periods of time, for minutes at a time. If your processors are sitting over the 50% mark, that might be worthy of looking into. If they're sitting in there and they're holding their own and they're still staying around 50, I wouldn't keep that as a huge threshold. But where we go into red alert, where we go into warning, where we need to have SCOM setting off alerts, is when, for again, key for extended periods of time. Once we get over 80% of the utilization for extended periods of time, then we're probably bottlenecking the server. We probably either have a rogue process that's gone Mustang on us, or we're underpowered, which is becoming more and more prevalent these days because I'm seeing more and more folks embrace virtualization, and that's great when the tool is used properly, and it rarely is, because what people will do is they'll say, "Oh man, these are virtual machines. We can, we can throw a single processor at this workload that we used to have, 32 processors running, and then they'll also shorten up all the other commodities as well, and they'll then wonder why things just run like terrible. And it's why we need to definitely be looking at that. So over 80% of the time for extended periods, that's a problem. And in this case, we can see that all the cores were up. What you might see if you hadn't loaded the individuals up is you might have seen, just one process going up, and then you need to investigate processes and see if you maybe are getting a complaint from a user because of a single threaded process that is just killing it. Also, you notice that I had the total in here. That's one thing you probably should always ditch, but I left it in here so that you can see that it is not a total. Even though it says it's a total, it is indeed an average. So the average of these two cores turned out to be the underscore total mechanism here. So anyway, we can see there's a problem. We've got something going on. And what you might be thinking is, immediately after having done this, what do I need to do, Chris? I need to go in and load up all my process and do process analysis and figure out which process is sitting at 100% or near 100% in this case, and sucking up all of my processing time, my key cycles for doing jobs and stuff. But the actual thing you need to do first before you go there is take a look at a couple of other pieces. Okay, this other counter where we're going to go in here and grab, you would think would be in the processor object, but it's not. It's actually in the system object, and probably should have grabbed it when it was in here, but it doesn't have a threshold necessarily. And this is the processor queue length. The processor queue length is a measure of how many packets are currently queued up, jobs are currently queued up waiting for the processor to be able to come through. Now, the queue can actually be reordered by the operating system, because there is a thread dispatcher that sits in front of all the cores and decides not only which of these two cores here the jobs are going to run on, but it's also deciding who gets to go ahead of who, right? So you've probably noticed in the details that we've got all of these processes running here and running there, and they're doing their thing, but there's actually, each one of them has little threads that they're sending off, and each of those threads are going to have a priority, and those priorities will tell the other or the thread dispatcher what to go and do with itself when we have a higher priority process come through. So if we talk about that, we can see it right here in this thread priority. I am no good with the whole drawings thing, so let me try that again, and I give up. Anyway, what you do is you see this drop down. You'll see that we can have things in, critical, highest, above normal, normal, below normal, lower, and idle. If I'm a normal process, and most of them are just kicking along and doing their thing, and somebody that is marked as an above normal process comes in, the processor will actually context switch. It will stop doing what it's doing on my code, and it will put me on the shelf, and then I go back into the queue, and then this other higher process, which can also be therefore preempted by something even higher, such as here in highest, the processor will then process that code or this code, depending what all is in the queue. And we go back into Task Manager. You notice that you've probably seen this forever. We can go and change processes manually. We can change a process's priority by just right-clicking it and setting it here. You can also override the thread dispatcher's ability to take a process and stick it onto some of the processing. You can stick it on one core, and you can then turn around and bump it up on its priority to a higher priority, and then it pretty much owns that core, That's one thing you could do. But anyway, the queue length measures all of the jobs that are waiting. So if you were looking at a capture like this and we saw high processor utilization and there were a lot of jobs that were coming in, what you would see is an increase in the queue length, assuming there were other jobs that needed to go. But again, I didn't dump that in there because it's not a key indicator and there's not any threshold I can really put on that. You could have a larger queue length but be sitting at a lower processor time. And if you do see that, check your C states. But as long as as long as the processor are sitting at a lower percentage, you typically will not see queuing in the processor. If it's got the cycles, if it's got the clock cycles to give, it will give them. But if you have a lower priority process, which is pretty rare, normal priority processors are just going to kick it out of the way every time. So if you only have 2 cores like this poor little VM does, and you have a lot of lower priority processes, give it more processors. That's the bottom line. Go in and assign more to your VM or put it on a machine that's got more things to run it on. Okay, so enough about that. The next gotcha that we need to look at here is going to be in processor as well, and it's that percent of privilege time. And we're gonna be looking at that one next. And in this case, I'm just going to dump in the total. And we can see that it's pretty low down here. So I'm not going to be worried about it at this point. What I might be thinking at this point in time, if I saw the privilege time sitting at maybe 10% up to, or 30% up to about 50%. So first thing that we got to call out here, that would have been cute. First thing we need to really call out here is we need to call out that if the processor time just overall is not over the, let's say, that 80% mark that we talked about, then don't worry about it. But if it is, then our next threshold is for high kernel time or percent of privilege time. If we see that getting above the 30 to 50%, so let's just kind of mark it around here. If we had seen this counter right here and that was sitting there at, like we saw it at over 80%, then we're going to look at one other counter first. And that counter is going to be the percent of interrupts, or 2 counters. I don't know why I said 1 counter. So percent of DPC and interrupt time, and we throw those in. And now we're going to come and put the highlighter on them. And you can see that the total of DPCs was not very high, and the percent of interrupts are not very high. Where would we have gotten concerned about them? At 20%. So at 20%, I am not thinking that one of the processes, even if I do have a process that is high CPU utilization, but if I'm seeing high percent of processor utilization and I'm seeing kernel times over 50%, and I'm seeing the interrupt time or the DPC time, those deferred procedure calls are basically 2 different kinds of interrupts, the easiest way I have to explain that. If either of those 2 things are happening, I would suspect hardware. At this point in time, your processor is spending 1 out of every 5 clock cycles having to service an interrupt from the hardware, and that's bad. There should never be a time when there are that many interrupts coming from the hardware on your system that they need to interrupt the processor what it's doing and make it stop doing those user mode processes and instead answer hardware calls. So that's something I'd be investigating. Do we have an issue with a driver? Do we have a potential hardware fault or pending failure, something getting ready to go there? So that's the gotcha I wanted to point it out, is that you don't treat this the same way that you would just using Task Manager or using Resource Monitor. We're actually going to need to go ahead and dig in. Now, if you don't see those 2 things, but you are still seeing high percent of privilege time, then there's one other thing you want to look for, and that's going to be almost at this point, I would say, oops, wrong counter, null and moot, because you would have gone and looked for this anyway, but it is interesting to put them in here, and that's context switches per second. So if we come down here and look at our context switches per second, if you're over about 20,000 of these, and I would say that probably holds up to about maybe 16 processors, and then 40,000 for anything above that. But if you're sitting over here at about 20,000, right now we're at about 3,000, I would be suspecting that we may have an issue with a program, either thread leaking, or we're looking at probably processing, more and more threads. So I'd be suspecting a thread leak at that point, and that's one of those times when I told you not to put thread counters into your black boxes. This is one of those times I go ahead and load them back in, because I've probably got some process out there that is leaking threads, and all these threads are now taking the processor and causing it to context switch and do transitions at high rate. If you're having to do that at over 20,000 times per second, then there's probably an issue with that. So those are the gotchas. So let's just go back to core troubleshooting again. Percent of processor time. That was the important ones, right? We didn't see any of those things. So what we're going to instead do is we're going to do process analysis, which is what you were expecting to do anyway. So we get into our process counter. We look at our percent of processor time. I am not using the percent of privilege time, though if I'd had high context switches per second, I would be. And that's when you use this. Every other time, which is going to be 99.999% of the rest of the time, you're going to do all instances on just plain old percent processor time. You're going to do the exact same troubleshooting that you do when you're using Task Manager. There is one final gotcha, unless I think of another gotcha, and that's going to be that, and I'm putting 200 in here because I'm cheating, because I already know the answer to this little question. I would say that this is one other gotcha that you have, and that is that your, totally hit the escape key too many times. Your processors can't go over 100%, but your processes can. And in fact, they went over 200%, which is a little bizarre. So I said I knew the answer. Obviously, can't be that much over. There we go. See, it wasn't over. It was just at the top of the graph, and we couldn't see anymore. So how can anything be over 100%, right? Oh, okay, that's the total. Let me kick total out, and then let's use our highlighter, and we will click on that, and we'll see CPU stress. But it's over 100%. Why is that? That is because we have a multi-core system. If I had a single core system, no process could ever go over 100% processor utilization. But if I have a two-core system like this one, we're looking at as much as 200% processor utilization. If I have a four-core system, you might see processors jumping up to 400 and so on. So anyway, yes, it's a percentage counter that actually goes over 100. So lots of oddities as far as the underscore total being average and percent being more than a percentage, etc., etc. You might be thinking, oh my gosh, Chris, what is that other one? It is taking up everything. You're right. You've seen it before. This is your idle time counter. So I would say, in addition to dumping the total, so you don't fool yourself, immediately also dump the idle time counter. And look for patterns. So do we see a pattern here? Is there a pattern right in there that matches to the pattern of the processor utilization? You betcha. And that's pretty much open and shut case. And as I promised, this episode was going to be a little shorter than the last couple, because troubleshooting processor performance just really isn't as difficult as some of the other things that we look at, and so that's really all that goes into that in most of the cases. And so anyway, folks, this has been Chris with Microsoft, and as always, I thank you a ton for watching. If you did find anything about this useful or interesting, please give it a quick like. That'll help other people find this series if they're looking for similar type of topics. Also, feel free to subscribe to my channel. That'll help you by giving you a notification whenever I put new episodes out. Also, my blog is at 9z.com. That is real easy to remember. It's just the last number followed by the last letter, .com. And that's also got links to my Facebook, my LinkedIn, my Twitter, and my TechNet blog. So again, as always, I thank you folks a ton for listening, and I will see you in the next episode.